Alright, you got that problem ready to go from yesterday? And get it written up here and we'll go through and see how you did. It was the first equation was 6x plus 8y minus 6z, and on the right one?
Yes.
Okay, can't make sure. Wouldn't it be good to start you off with the wrong problem?
That's not wrong or right problem.
You gotta switch the Y and Z.
Oh, thank you.
I looked at this YouTube video on this last night, and he had on his first problem, it was like X, Y, Z, and then on his next problem, it was like Z, Y, X, and on the next one, it was different, so
Yeah.
I couldn't, I watched it, but it was confusing.
You just gotta reorder them. Okay, I'm going to go through this starting from the front again and get caught up with you. But what I need for you to remind me as we go, because I did this problem in all 4 Algebra 2 classes, and I don't know if we did it the same way or not. So I'm going to assume that the first thing we did was put the first and last one together. Is that right? And eliminated those y's. Okay, so that's going to get me 6x plus 8y minus 6z is equal to 62. We're going to do more of these today. That's why I wanted to start over and do this whole thing again so you would remember the process that we went through. Now my 8y's are different signs, so that means this is an addition problem. 6 and 12 give me 18x's. 8y, negative 8y's, nothing. He gone. Negative 6z and 20z. Negative 14z, and 62 and negative 68 is negative 6. We good on that? Alright, so that was my new equation number 1. I'm not going to lose it. Now, for our next step, did we put the first and second one together? Bless you. Anybody remember? We did, thought we good, so I'm going to put, yes, Trevor.
Negative 6 plus 20 is negative 14?
No, it's positive. Thank you, Trevor. That would mess us up like crazy and down the road. Thank you, Trevor. Everybody see that mistake that I made? Y'all didn't have that on your paper though, did you? Good. Thank you, Trevor. All right. Now, so we had to make, when I've got my blue ones linked there, my y's are not the same. So we talked about what they would go into. The smallest thing they'll both go into is 24. So I need to make this 8 and 24, I need to multiply by 3. So I'm going to multiply that whole first equation by 3. Be 18x plus 24y minus 18z. And what did that equal? 126? 186. Thank you. And then I had to multiply this whole second one by 2 to make that a 24. So that would be 20x minus 24y minus 28z equals 28. Now our y's are different signs again. So
wait, the first one was by 3 and the second one by 2?
Yes. Right. Yes. Did I get it right? Okay. So it's addition again. So it's 38x. That's gone. That'd be negative 46z. And for 214, is that right? Alright, so I'm almost caught up with where y'all were. This is where it got no fun. The one that we had done together in our notes before this one, when we got our 2 highlighted ones down there, we had something the same. But now we don't. So we're looking at 18 and 38. What can they go evenly into? Or on the Z's, 14 and 46. What will they go evenly into? When you can't find something that they go evenly into, you can always multiply them together. So whatever 18 times 38 is, they'll go into that. Or whatever 14 times negative 46 is, they'll go into that. Okay, so did we do the x's? Is that what I suggested to y'all? Alright, so we're going to multiply this one, whole thing, by 38. Alright, I'm going to need help. So what's 18 times 38 on my x's? 684x.
What did you do at the bottom of
Did you get something the same?
No.
Okay, so you would still, your work's gonna look different, but as long as you don't mess up, we'll still end up with the same answer. It's possible. I mean, you can do that.
Oh wait, I have a question real quick.
Uh-huh.
The thing, didn't you say something yesterday, like if they're the same, we'll subtract, or if they're different, add, or something like that?
Yes, if the letter you're getting rid of is different signs, you add. If they're same signs, you subtract.
Okay.
Okay? All right, 14 times 38. What's my z's? 32 on my z, and then negative 6 times 38.
Negative 228.
Negative 228. Okay, so now I'm going to take my blue one, and I got to multiply all of it by 18. Okay, so 38 times 18 we know is 684. What's negative 46 times 18?
Negative
828. And then 214 times 18.
3,852.
Alright, so now we finally have our x's the same. 684, 684. Chloe was just talking to us and reminding us, are we going to add or subtract here? Subtract, because those are both the same signs. They're both positive, so we'll throw a subtract sign there. 684x minus 684x is nothing. Keep going. Okay. Be careful of your signs now. On my z's, 532 minus negative 828. Uh-huh. What do you get on that?
14.
Go ahead, Dalton. 1,360 z. And then negative 228 minus 3,852.
Negative 4,000.
Alright. What's our last step? We can get z now. What's our last step? Good. And you get negative what? 3. All those humongo numbers, and we end up with a good old normal number for our z. Okay? Anybody get there's z right, or did we do that together? We did. You did? Good. You did? Good. So we got a few of you that did. That's good for your the second one. Okay? Now we got to plug that in somewhere to find another letter. Okay? We've done all the harder stuff, so it's just substituting in. I would take it back to one of these highlighted ones. I had some people yesterday say they wanted to plug it into one of these. You could, but look how much bigger your numbers are in that. You're going to be making humongo numbers here if you're multiplying something by, that was my z, if you're multiplying it by 532. So I would go back to one of my smaller ones and plug it in there. So do you want to plug it in the red one or the blue one? Red. This one wants red, so we will do red. So I've got 18x plus 14 times negative 3 equals negative 6. Then we do 14 times negative 3, and that gets us negative 42. Okay, now you got your two-step middle school equation to solve. What will we do first?
Plus 40.
Good job. So it gets us 18x is 36. Is that right? Divided by 18. You got an x there. You got 2. Good job. Okay. Did you do the same?
I did the other.
Okay, I'll have to just go back through your notes and try to look and see where we went wrong in it when I get a chance. Alright, so now my last step, I gotta get my y, so I gotta take that x and the z back to one of the original equations. So let's go through and pick our favorite original one. The top one's 6x plus 8y minus 6z. 6x plus 8y minus 6z. And that equaled what? 62? 62. Alright, so we got 6x, so 6 times 2. We don't know our y. Minus 6 times negative 3 is equal to 62. 12 plus 8y. This negative times a negative makes that a positive 18. I got like terms, 12 and 18, so that's 30. Stephen found his mistake, good job. Subtract your 30.
Divided by both negatives and thought one was positive.
8y is 32. So there's your y. So
I
I,
did not get
well, because you got a different one to plug back in now. Remember when you plug the wrong sign in, that'll make you get a different answer, so you have to go back and plug it in with the correct sign. That'll change that answer. Alright, so we got x, y, z. That's our answer. You didn't do horrible for your first try at one of those. We're going to do some more. Oh, Chloe, you did not.
It took me forever to figure it out, and like I had the first step right, and that was probably it.
Alright, let's go back and everybody got copied what you need off that, got it ready to go? Okay, got you carried in. Dadgummit, I'm still gonna get a drink. I wanted to drink a coffee when she said wait, and then she said I'm good before I even got to the coffee cup.
One of those problems takes up like a whole piece of paper.
I know it, I know it.
That's really good.
Yep. Yep. Well, I was glad that Trevor pointed out I wrote something down wrong, because I'd have done all that work and it'd have been wrong. Alright, let's try here. X minus 2y plus z is equal to negative 11. And then I've got 3x plus 2y minus z is equal to 7. And then I've got negative x plus 2y plus 4z is equal to negative 9. Now if you look at that and let that soak in, this is going to be a breeze compared to that one that we just finished.
All the Y's are this.
Very good. All those y's are ready to rock and roll. We don't have to multiply by anything. We don't got to make 24s like we did on that last one. Those y's have all got a 2. Anytime you got something that's all got 2, it's good to go. And Carrie Lynn's already seen something that's going to happen in a minute. Not only are these y's going to maybe eliminate, but we might also have a 2-for-1 special here in a minute.
The X's, yeah.
We could if we choose to go that route. If we choose to put the first one and the third one, there could be another 2-for-1 special. When you get a 2-for-1 special and 2 of the variables go away, then you already know one answer. So that's always a big time saver, and that'll be good for us. All right, so we agree. Let's do the y's because they're 2's all the way through. The first one and the second one together the first time, is that okay? Because that takes the y's and the z's, and then for our other one we'll do what Dalton saw on those x's, but we'll go ahead and do these right here. So that's going to get us x minus 2y plus z is negative 11, 3x plus 2y minus z equals 7. Are we going to add or subtract these?
Correct.
Look at the signs in front of your y's. Add, because the signs, that's okay. The signs in front of the y's are different, so you're going to add. Okay, you go ahead and add them. I'll give you a second. You go ahead and add them. See what you get on that. And just stop there.
Wait, wouldn't the Z's cancel off since there's a positive and a negative?
That's what, this is a 2-for-1 special. That's why we like this. So it's just going to tell you what x is. You can solve it for x. It's not 18. Negative. It's a negative 11. You got something there yet? I need some assistance. Alright, Molly, how many x's do I start off with here when I just add these? What's x plus 3? What happens to my y's? Good, negative 2y plus 2y, he gone. 2 for 1 special, z and negative z, he gone. Hot dog, negative 11 and 7, negative 4. So look at how short it is when we get a 2 for 1 special. We already know an x. Okay, now, good. That's a lot faster than that last one, but I don't have anywhere to plug that into yet. Okay, now, earlier Dalton saw something good. Well, the first one and the third one, the x's would cancel out on that. But now I don't think I want to do that, because I've already got an x to plug in. Well, no, maybe I do that. It'll already tell me the z. If I do, okay, Dalton, if I do the first and the third one, what I was initially thinking was I didn't want to do that because the x's are going to cancel out, so I wouldn't have anywhere to put my negative 1 in. But, no, yeah, the y's are going to cancel out also. So that will be the other, that's where Dalton was guiding me that way. So I'll get a z. Okay, so let's look at that, the first one and the third one. X minus 2y plus z is equal to negative 11. Negative x plus 2y plus 4z is equal to negative 9. So I'm gonna, my y's are different signs, so that means I'm adding. And here's another 2 for 1. X and negative x is nothing. He gone. Negative 2y and 2y is nothing. He gone. Z and 4z. 5z. Negative 11 plus negative 9. Negative 11 plus negative. Good. So you got a z of negative 4. Bless you. Okay. Now remember, we always, this was my words, there's new equation number 1, don't lose it. We hadn't even had to mess with that here because we've gotten lucky and got the 2 for 1 specials. So we already got an x, we already got a z. We just got to go plug that back in one of those black ones there and get the y. Either 2 or 3, because Carolyn likes a positive y. How about the second one? Is that okay with everybody? Okay, so I'm going to go to the second one. I've got 3 times x plus 2y minus negative 4 is equal to 7. So that gets me negative 3 plus 2y minus negative 4 is the same as adding 4. Now you got some like terms right here. Negative 3 and 4, that's 1. So now you've got your 2-step middle school equation. Subtract 1 from both sides. 2y is 6. You got it, dude. Y is 3. So we've got x, y, z. I'm going to let you get that digested, and I'll tell you a little bit about it, and then we'll try another one. When we start getting those 2 for 1 specials like that, that always creates some confusion. Because you look back at your notes to try to compare how we did the other one, and you don't have that same list of steps. It didn't take near as long, or I don't know what to do. When in reality, that was way shorter and way easier, because bam, 2 variables went away, bam, 2 variables went away, you just plugged in and solved. Okay, so it was good that we got to see something like that so that you don't panic and not know what to do when we get something. How often do you see these, the 2 for 1 specials? Every now and then, but every now and then. Okay, more of them are going to be the longer kind where you don't get a 2 for 1. I like 2 for 1 specials. Alright, let's try another. here I got x plus y minus 2z is equal to 5. Then I've got negative x plus 2y plus z is equal to 2. And then I've got 2x plus 3y minus z is equal to 9. Alright, I want to let you try one, but I want us to kind of try to do the same thing. So let's try to decide what would be a good way to start before you take off on your own.
The X's.
Okay, I could put the first two equations together here and not have to do any work and get rid of the x's, right? Then I could put either the second two together or the first and the last one together, and I'll just have to multiply something by 2, because then they would have to be 2's, right? So that's a good option. The z's would be a good option, because you could put the last two together and they're gone without any work. And you can put the first two together and just have to multiply this one by 2. Okay, so you're going to go with, and you can do either one, I don't care. I would like to only have to work the problem once though. But Trevor's working on x's, is that what everybody's okay with? Okay, so see if you can set that up and get the x's. I would go here the first time, put those two together. Let's see if it would be a good idea to do the, yeah, I think you could get a 2 for 1 maybe, no, because they're same sign. Oh, but they're both same
What?
signs, yeah.
Yeah, it's two different sums. Right?
I was knowing
Oh,
myself, I'm
okay.
sorry. I was trying to think of which two I wanted to put together next. I don't think it matters, there's not a 2 for 1. So I'm just gonna put those two together next. Alright, see, just get started. If you start struggling, we'll throw you a rope.
One Z and Z is the same, right?
Mhm.
So yeah, it's the same.
If you're stuck, all I've done is got my two new equations.
Where'd you get 4y from?
I had to multiply that whole second equation by 2 to make that be a 2x. Because we eliminated the x's in the first round, we eliminated the x's, so I got to eliminate the x's here. This one's got a 2, so to make this one 2, so I had to multiply everything there by 2. Okay? Anything else that you didn't remember or you don't understand why I did it. Tell me so I can help you, I don't mind.
What'd you say you just did?
For my first blue one here, I multiplied that whole second one by 2 so that I could get rid of my x's.
Mm.
Did you get that red one that I got, Trevor?
Yeah.
Okay. What two, did you choose 2 different ones than I did here?
Thanks. No.
So
I got rid of the Z.
Well, remember, whatever you get rid of in the first one, you have to get rid of in the second one. So that's where you went wrong on.
Yeah. Yeah, now I see that.
And now in your highlighted ones, that's good news. Why is it good news in my highlighted ones? Good, the Z's are ready to go away, right? Are y'all doing that now? Go ahead and go there. Stack that red one on top and the blue one on bottom. Z's are both a 1Z. They're different signs, so it means it's an addition problem. What did I get for a Y?
2.
Good job. Okay, take that Y back to one of your highlighted ones and plug it in and solve for Z. Austin, which one you want to plug it in, the red or the blue?
Red.
Okay, the red, so I'm going to have 3 times 2 minus Z is equal to 7. So that's 6 minus Z is equal to 7. Subtract your 6. That gets you something that's a little bit weird. That gets you negative Z is equal to 1. So what do we got to do when we get a negative Z? Good. So that means Z is negative 1.
Now you plug both them in one of the start equation.
You got it, dude. Go back up and pick a favorite original one and plug both those in to find X. Since I want X, I'd probably pick the first equation since it's got just X. X plus Y minus 2Z equals 5. X plus Y minus 2Z equals 5. Alright, so we've got X plus Y minus 2 times Z is equal to 5.
Can you do 2 times negative Z? That's like one of the equations. Never mind.
Okay, so it gets me X plus 2. Here's where what the area tremor was. I'm not real sure exactly what it meant.
All right.
I got a negative times a negative, so that's going to be a positive there.
Yeah.
So that's 4. So you know your X. X, Y, and Z. Alright, those that we've done so far are the normal ones. You know, remember we started this off by saying that these were planes that were going to intersect in space. And so normally planes will intersect that way. Planes can be just like lines though. Some lines are parallel and they never intersect. So if you had parallel lines and you were solving them and they never intersected, it would be no solution. Sometimes a line is the same line, it just looks different. It lands right on top of itself. those would have infinite many solutions. So you got those instances where you get those different types of answers. So we got to look at what that would look like with these planes real quick. So,
Of course.
yeah, everybody done with what you need there? Alright, I've got x plus y plus z is equal to 2. 5x plus 5y plus 5z is equal to 3. 4x plus y minus 3z is equal to negative 6. Alright, so we don't have anything that's all the same, but that first one's got all ones, so it's easy to change something. So what do you want to get rid of? X, Y's, or Z's?
X.
Okay, X's. So if I wanted to put these first two together, I'd have to multiply everything in this first one by 5, wouldn't I?
Yep.
So it's going to make 5x, 5y, 5z. That looking familiar? But then 2 times 5 is 10. Okay, then my bottom one already has a 5x, so my second one, so I'm just going to rewrite that second one. Trevor see something funny? We all ought to. My x's have same sign, which means subtract. Talking about more than a 2 for 1 right here. 5x minus 5x is nothing, he gone. 5y minus 5y is nothing, he gone. 5z minus 5z is nothing, he gone. So what is on the left side of my equal sign?
Nothing.
Which would be mathematically a 0, right? So all I've got on the left side is 0. Over here though, what's 10 minus 3? 7. So we've got a sentence there that says 0 equals 7. Is 0 the same as 7? No, that's wrong. 0 is never 7. 0 cannot equal 7. When you end up with something that's dumb, that's stupid, that's a wrong statement, that automatically means you're done. You just have to write your answer as no solution. A circle with a slash through it means no solution. A lot faster, a lot easier when you get a false statement. There's no variable there. It's just a wrong number equals a wrong number. No solution. 0 with a slash through it. Don't even got to worry about everything else. So that would mean those planes are parallel and they're never going to intersect. Okay? Everybody all right on that? Easier to understand why. That's just dumb. 0 doesn't equal 7. Right?
We can put that in each other.
That'd be nice. Okay, there's one more special kind. Here I've got x minus y plus z is equal to negative 3. And I've got x minus y minus z is equal to negative 3. And I've got 5x minus 5y plus z is equal to negative 15. Z's?
Yeah, the first two.
Okay, everybody see why I said Z's?
'Cause you can get-
Good, they've got all ones on that, so Trevor wants to link the first two together first and get rid of the Z's there, so write them over here. Okay, now on the Z's, they have different signs, right? What do I do when it's different signs? I'm going to add, so it gets me 2x, negative y plus negative y, negative 2y, doesn't go away, right? But here it does, z and negative z is nothing, keep going. And then what about negative 3 plus negative 3? Right? Everybody good on that? Okay, that's new equation number 1, don't lose it. Okay, we're getting rid of the z's, so now I need to decide, do I want to put the first one and the third one together, or the second one and the third one? Doesn't matter. So we pick first and third or second and third?
Second.
Second and third. I feel like Trevor's the official spokesman of second period algebra 2. That's okay. right? They both got a 1 there, so it's okay, it's ready to go. So I got x minus y minus z is equal to negative 3. And I got 5x minus 5y plus z is equal to negative 15. So these z's again have different signs, which means we're adding again. X and 5x, negative y plus negative 5y, negative z and z, he gone, negative 3 plus negative 15, negative 18. New equation number 2, don't lose it. Okay, looking at our highlighted ones now, we've got to decide what we're going to get rid of next. On my red one, I've got 2's on both of them. On my blue one, I got 6's on both of them. So I'm going to want to multiply the red one by what?
3.
3. So let's multiply this red one by 3. I think you're going to see something cool now. Gets me 6x times this one by 3 minus 6y equals negative 18. My blue one is also 6x minus 6y equals negative 18. Some of y'all notice it now. Those are the exact same equations. So if, go ahead, Molly. Okay, well, what Connor said, if we start, they've got same signs on my x's. If we start subtracting them, 6x minus 6x is nothing, he gone. Negative 6y minus negative 6y is nothing, he gone. 0. Negative 18 minus negative 18, 0. Okay, so we got a true statement now. 0 does equal 0, right? That's true. So when we end up with all our variables going and we just have that true statement, that means there are infinite many solutions. That means those planes are on top of each other, intersecting everywhere. Okay, so the false solution got us no solution. No, the false statement. Bless you. Bless you. Bless you. The false statement got us no solution. The true statement got us one solution. Oh, dumb butt. I said that wrong. Let's rewind and start over. False statement got us no solution. True statement got us infinite solutions. And then just those normal ones, what we've been doing all along, are one solution. So these last two are the different kind. You don't see those very often. So I'm going to go back and we're going to end on a normal one. It does have a solution, just so you get the normal ones back in your brain. Find a good easy one for us. X plus 4y minus 6z is equal to negative 1. 2x minus y plus 2z is equal to negative 7. Negative x plus 2y minus 4z is equal to 5. Alright, let me tell you about your answer on this so you'll know. There is one solution, so you're going to get an ordered triple, an x, a y, and a z. You're going to get that. They're all whole numbers, so if you get fractions or decimals, you've messed up somewhere. If this were up to me, and you do what you want to, if this were up to me, I would eliminate the x's. That's what I would do. I'd put the first one and the last one together, and then maybe the first one and the second one, something like that. Okay, so once this is yours. You've got it written down, you're working on it until we leave, and then if you don't finish, it's homework. This is yours. I gave you some good starting hints if you're not sure where to start. Put the first one and the last one together. Get rid of the x's.